We'll just go back and we'll do it. So the name of the presentation, where we're going, we don't need roads, a new way to image and deploy Linux VMs using Boot. We're going to talk about all that, what that means. I'm going to start off with introductions though. My name is Christian McLaughlin. I'm the current president of the Jacksonville Linux Users Group, a corporate association. My professional background, I was an electrician's mate. I worked on P3s and P8s, did 2 tours of duty and 3 deployments overseas. I was in Japan, Italy, Middle East. I know somebody said something earlier about their phone shutting off in this heat. My phone literally in the Middle East, if you had it out, would shut off after like 10 minutes. So you could not have your phone out for too long or it would just die. I decided to get out of the Navy after 8 years, and I wanted to get into information security specifically. I was pretty technically savvy at that point, obviously, because I was in avionics tech. But I wasn't really super computer savvy. I was, but I wasn't. I bought like the first Raspberry Pi when it came out. I've been using Linux at this point for a while, but I wasn't to the degree of where I am now. But I learned pretty quickly. And like I said earlier, the Jacksonville Linux Users Group helped me out tremendously in that growth. So I'm very indebted and thankful to this group of people here that I call my friends. My specialization right now is in vulnerability and risk management. So my background started off as a SOC analyst. I worked with that man back there. I then moved over to pen testing, did that for a while, enjoyed it, moved on, worked as a cloud security engineer for a little bit, and then moved on over, and now I'm working in vulnerability risk management. One thing I really love about vulnerability risk management is there's always stuff to do, especially these last 2 years has been insane, the amount of work I have. But I really do truly love it. And hobbies include cycling, shooting, piano, cooking, gaming, and most importantly, home lab. So what's my motivation for giving this talk? It's my home lab. Right there is you can't really see it that well, but it's my server rack. I think like half of it is a server rack. The other half of it is a network rack. If you see all that silver, that's all networking equipment. And then everything below it is video equipment, PlayStation, and a server, and then the very bottom are my UPSs, my battery banks. So I built this from scratch. If you're wondering how did I get here, it started off with a couple of Raspberry Pis. So to anybody that is interested, you really only need to start with a little bit. You will get equipment over time. You will find donations. You will find deals. People will literally give you stuff. And then eventually, when you make more money, you can buy stuff like I do. And then, you get this right here. And by the way, this is probably like a quarter of my equipment. The rest of it is scattered throughout my house, probably collecting dust. I donate as much as I can to people that need it. So if you're looking to get into home labbing, come hit me up. I can try to hook you up with some stuff. I will not give you RAM, sorry. I have my stores of RAM for the Rampocalypse. So, but honestly, the true motivation for this talk was my home lab, right? So it started off as a passion project, something that was fun. But as I grew, my motivation changed from how can I make this cool and fun, trying out little stuff, to how can I make this enterprise-like. And I know that's not everyone's like that, but my goal and desire to learn to make my home lab mirror an enterprise environment was partly my desire to grow in my career, right? If we're talking about skills translation, right? Why would I do something that, oh, it's just my home lab, when I could do it the right way, the proper way, put that on my resume and say, hey, I know how to build scalable infrastructure at home. So my entire motivation around my home lab has been just that. My home lab is growing pretty quickly. As you can see, I'm actually ready for my second rack at this point. I don't know when it's coming or when it will appear in my house, but one day I'm gonna split my rack up. I'll probably do like networking equipment and video equipment in one, and then all servers in the other. But one of the biggest things with my home lab, especially with Linux, was I needed to cut down on the time. So, and particularly with installing, configuring, and provisioning. So I do want to give some disclaimers real quick, since I did gave myself instruction. I don't know everything. Everybody in here is always learning. If you have questions, I encourage you to ask them. You can interrupt me anytime to ask questions. There is a question spot in the end if you want to save it, but please feel free. I will try my best to answer. If I don't know the answer for you, I will get you the answer later. I used AI to make the stupid tux images, but I can guarantee you that like 90% of this PowerPoint is not AI generated. Yeah, this is all like, you're gonna see typos everywhere. So, what are we talking about today? We're talking about Linux. I know the last couple of presentations that we've had maybe had involved Linux to some degree. This is a Linux talk, right? So we're actually talking about Linux, and probably one of the most fun things about Linux, which is installing Linux, right? We're gonna talk about how to not install Linux, so you can do other fun things. You have to focus on installing, right? So this is a different way of installing Linux entirely. It creates virtual images, which we'll talk about that later, for VMs. This talk involves Git, a little bit of GitLab. We talk about infrastructure as code, CI deployment pipelines, and the cool thing about this is, this whole talk is self-hosted, so I don't think there's any commercial, anything commercial. So if when we do the demos and stuff, it's all my home lab at home. So anything that I'm doing today, you guys can absolutely do at your home. So question, this one's for everyone here. How do we install Linux today, right? So like, what are some examples of how you want to install Linux on something, a computer, a Raspberry Pi, a router, you want to install it on as a VM, like what are some ways that we install today, right?
USB.
USB? What do we do with the USB?
I just burn an image and boot to the USB.
Burn an image, boot the image, then boot to the USB. That's like, I'm pretty sure it's like what everyone is thinking when you think of like, when you think of installing Linux.
The brand new Pis don't need that anymore. All they need is a Cat5 cable and an accessible internet access.
So Pixie boot, network booting. Yeah, Pixie boot. That's another one. Yep. What else?
You gotta go into your BIOS and make a boot from that USB first.
Yes.
And then usually get rid of the secure boot, because that messes up things.
Yeah.
Are there any other ways that we?
Use the ISO.
Yes, the ISO.
Download the ISO, burn it to a CD-ROM.
Yeah, you can do that. So as you can see, it's all about using an ISO. Are there any other ways besides using an ISO or Pixie boot?
Magnetic Windows user, you can download WSO2 and
Oh, that's true.
Yeah, that's true. That is technically emulation or virtualization.
You can still use floppies for some of them.
Yeah. Right.
Or CD-ROMs.
There's actually like one or two that I'm thinking about that people haven't mentioned.
You know, Stallman's famous for saying he doesn't install Linux. He's in groups like this, and someone else does it for him.
It's true, yeah. That has happened.
So you can always just use a magnetic needle and a hard plotter.
All right. So as you guys have correctly stated, ISO, the click-through install. You can use automated installs, pre-seed and kickstart. How many of you know what pre-seed files and kickstart files are? One person. You know what it is? You know what it is? All right, a couple people.
That's how the new Raspberry Pis are actually connecting to the net, straight into
Yeah?
Adafruit and getting whatever you
Yeah. So I learned about Kickstart files about 2 years ago, I think, and I've been using them extensively. All you do is you feed a Kickstart file into your system, and the Kickstart file is just a set of instructions on how you want your system installed. I'm going to give you guys a hint. I don't know about other distros, but if you install something like Fedora or Alma Linux, it generates a Kickstart file on your system. So if you need to redo your system the way that you did it again, you could just use the Kickstart file that they supply. The Kickstart file includes things like the user accounts, the credentials, the hashed credentials that you used to generate it, the partitioning of the system. Like, these things are very important. You don't want to sit there and have to click through all this stuff automatically, right? So like an example, this is Fedora. So if I go under, I believe it's under, oh yeah. Oh, whoa, that did not do what I wanted it to do. That was the wrong zoom. Wrong zoom. There we go. All right, I believe it's under root. Don't have permission for root. Now I do. Oh, no, yeah. Now I do. All right. So, it is the, are we under root? We are. I'm pretty sure. It is the, is it initial setup? I don't think it's that. Oh yeah, it is. Yeah, it's a Kickstarter file. Yeah, sorry, it was named something else on Alma, I believe. But this right here, this is not what. Okay, so yeah, this is a Kickstarter file, but this is not the Kickstarter file that I got. So I don't know why I didn't do it. If you do it on Alma Linux, I know for a fact that it does provide you the Kickstarter file. And to be honest, that was kind of where I got down that journey. Like I was like, what's this Kickstart? Like somebody mentioned Kickstart. I saw the Kickstart file in my system. I started tweaking with it, messing with it. I realized that you can use Kickstart files and other files. Like you can point to those and like use them as like supplemental files and stuff. Anyways, Kickstarter is really cool. If you haven't heard about it, Precedes is the same thing. It's the Debian equivalent, but Kickstart is so much more fleshed out. The other thing too is you can use cloud files. I don't know, nobody mentioned that, but if you go on any distro's website, there's cloud images. They're usually going to be for like QCOW or raw images, but you download these pre-configured images, and they have like the basic settings, and you can apply scripts to them, like Ansible scripts, or you can do like Cloud Init scripts, so that way when you boot that image on first boot, it just configures it for you. That's another different way of using cloud images. One other thing too is pre-existing images. So this is actually how I did it for a while. I would go and I would install the distro, or I would install my image, and then I would just clone it. And if I needed to make more changes, I would have a templated image and I would make the changes in there. But I'm gonna tell you why that is such a bad idea. It's great for, again, great for home labbing. It doesn't scale very well, right? This is like a learning process. And you know, you guys are gonna find out how I got where I got 2 years later. So where legacy media fails, so every VM, you're just going to talk about now at this point, you know, desktops are great and all, we're mostly talking about servers and stuff, but every machine is going to, needs to be managed, right? And there are tons of tools out there to do that. Ansible is a fantastic tool for doing that. Ansible kind of has been used a lot when there are better tools to do the job, right? Like you might have two tools and they both work, but there's better tools, right? And Ansible, I would say, is great for certain things, but we use it a lot for, you know, things we shouldn't when they have other options. So drift and mutation are the two of the biggest things I want to talk about. So the moment that you fire up a machine, like let's say I created that image and I cloned it and I made two separate images and I booted both of them up. The moment that those two machines boot up, they are immediately different from each other, right? The moment I go sudo dnf update y, they are immediately, now they might receive the same updates. There might be some issues. Maybe one of them might have like had a configuration or like a configuration change that caused the update to not pass, or I installed a package on another system that the other one didn't have. They immediately start mutating and changing, right? So it's very difficult to maintain that state, and the state is something that we're gonna talk about later, right? So the other thing too is rollbacks are possible. So does anybody know what rolling back a machine means? Especially for virtual machines. So when you have a VM, you can create a snapshot of that VM. This is really good if you're ever gonna do something that's risky, or like you're not sure how you want to, like how it's gonna turn out. You take a snapshot, it captures that image in that time. If you break it, you just roll it back, and then it's just like it was before. Exactly how it was when the snapshot was. You can do this over and over and over again. That's how you would roll back a machine state previously. It is not a form of version control. It is just a form of like, oopsies, my bad, I need to roll this back. The interesting thing is that you can create multiple snapshots and you can go back, like if you need to go back a week ago, oh no, I need to go back a month ago, oh, I need to go back to a week ago, like you can do that. It is not the best way to manage that. So I started off, how many of you were here for January's meeting? Probably not super many, maybe like I think 1, 2, 3, 4. I know a couple of you were here, they aren't raising your hands. So I talked about a tool that I created called KVMage. KVMage was what I considered to be the solution to the problem that I had, right? So why did I create a tool instead of using one that existed? Well, I'm using KVM as my hypervisor, which we'll talk about. The hypervisor is the machine. Who doesn't know what a hypervisor is? Who doesn't know? So a hypervisor, I'll just explain it, is a machine that manages your virtual machines, right? So I use KVM, which in my opinion is the best hypervisor. I will fight anybody that says that, that VMware or whatever is better. It is not. KVM is superior in every way. I use KVM. KVM has this really cool tool called libvirt, like the verse commands and stuff. I love them. With libvirt, you can install and configure VMs with its own tool. You can do virt install, which will install, you would take like the ISO file and the kickstart file, and it will just install it for you with KVM. And then you could go a step further and say, oh, I want to configure another image. So I would just say, hey, I'm going to inject this shell script into it and execute it. And the shell script just has a bunch of install, like set up this user, install these packages, like make these changes, and then it would just do it. I love that. I wanted that in my environment, but I wanted a way to automate it. So there were ways I could use scripts, but I was like, nah, I think the better way is to use a tool. There is a tool that exists to do this. It's called Packer. I freaking hate Packer. I knew I had a hate relationship with Packer the moment I installed it, and I had a conflict. And it said, Packer already exists on this system. You need to, and then I go to Packer's website or HashiCorp's website, and they said, oh yeah, in some systems you have to rename Packer. And I said, I'm not doing that out of spite. I was just like, I'm not doing that. So I also don't like HashiCorp because it was bought out by IBM, and I'm just not a big fan of IBM at all. And HashiCorp is just now a corporate shell. They make good products though. We're going to talk about another one of their products later, kind of, sort of. This tool was purpose built around. What's up? This tool was purpose built around libvirt, which is great. It had a lot of quirks, but it was honestly my first tool that I mean, I'd never considered myself a software developer before this tool. I still don't consider myself a software developer, but it was my first tool that I actually developed, like version control, like actually learn how to use Git properly, and you know, and I'm really proud of it. I don't use it that much anymore though, but I do still maintain it, and it is still pretty useful in very rare occasions. I build my domain controllers with this tool because, as you can imagine, domain controllers aren't something that you want to live in a stateful environment. You kind of want them, they're like one of the few things that kind of just needs to be installed and managed. So so this is where I found out about Bootsy. I do not remember exactly how I found out about this tool. I think I was going on the internet and I was learning about like how software developer, about how infrastructure engineers are using containerization to manage and deploy virtual machines, which I thought sounded cool already because I'm a huge fan of Docker. I use Docker extensively in my environment. Docker, Kubernetes, very big fan of those tools. So I guess I did some digging and then found out about Bootsy. Turned out, hey, this is for RPM-based distros. Awesome. In case you don't know, I probably say this more than I say anything about Arch. I use Alma Linux. I love Alma Linux. I started with CentOS right when CentOS went dead. So I was like, I'm gonna use CentOS, and it hit end of life. And I was like, that sucks. So I needed an alternative. Found out Rocky exists. Rocky was made by the guy that created CentOS, right? So I just used Rocky, and then eventually found out about Alma Linux. Went and tried to figure out what the difference between the two is. In case you aren't wondering, Alma Linux is a 501c3 nonprofit company that is ran by its board of directors, and Rocky Linux is it's a for-profit company that is ran like a not-for-profit company. That managed. The product is managed by the community, so it's very community focused. But the main difference between the two, besides how the companies run their products, is Rocky Linux tries to be one-for-one Red Hat Linux, right? Why would you not want to install Red Hat Linux? I have nothing against Red Hat. I just don't like entering license keys in all my systems, and I don't like being limited to 20 machines in my environment. So Rocky it is. Alma Linux when I discovered what it was, is actually different. They take a different approach. They don't wait for Red Hat to fix bugs. They just fix it themselves and then also do the performance improvements on their own. They do try to be as close to Red Hat as possible. So if Red Hat figures out a problem that they've solved before and it's suitable, they revert back. But you will see Alma will release sometimes before, like their next version before Red Hat, and whereas Rocky will be afterwards. So I like that. I like the idea that these guys are taking a product and they're not trying to clone it and be Red Hat. They're different. So big fan of that. So I found out about Bootsy. It is a different way of installing Linux entirely. It is used for scalable environments for creating virtual machine images. The operating system is packaged very similar to a container image. We'll talk about container images and later in virtual machine images and how they're different. So it uses like the OCI image format, which is again way different than a virtual machine image. And it fixes so many things. In case you can't read that, I'll read it out. Drift and mutation from daily instance usage. It is a stateful and hit, like DNF update, right? And Ansible will run a script and hope and pray it updates 100% of your environment. You could just manage 100% of your environment this way. It's a way of safely, those who don't know, that is a way of releasing software, right? On systems, when you don't have to install the software directly on the system, you deploy it as this little tiny container, like a little packaged bit of software on a Windows system if one of them is AMD and the other one is ARM processor, right? That's like one of the biggest differences I ran into. So the thing about that with the software development mindset is they work on versions, they work on like version control, and so when you're deploying things in versions and steps, if something breaks, you just roll back the version. Well, it's the same mentality with virtual machines with Bootsy. If something's wrong, you just back forward, however you want. It doesn't matter. The only thing I would say is that there are certain things where if you're migrating to a new major version, you might have to make changes. That's like the only time where you probably can't revert back to an older version. But that's why you keep backups. Everybody keeps backups, right? Cool. That's what I thought. So system images follow the same pipeline as your apps. I honestly, if you just think of this as a tool versus as a state and a flow, this might not be a big thing for you, but if you're a software developer and you are so specific on working a specific way, the fact that you can deploy your infrastructure the same way as your applications is mind-blowing, because you don't have to sit here and spend extra work redesigning how you deploy something, right? Like I said, it uses the same concepts as tags, registries, layers, signing, and file structure. I understand I probably might have lost some of you. I'm gonna try to catch everyone. Oh, sweet, I did not know that was next. I'm gonna try to catch everyone up to speed. I needed to lay down stuff in front of you guys, and then we're gonna catch up. What's up?
Is that kind of similar to NixOS?
So NixOS is a stateful operating system that you describe, and it's very similar in the way that, yes, it is quite the same. However, NixOS is built to be like that, whereas this is more like a architecture. So like it doesn't matter what version you're using. It was originally released for RPM-based distros. You can now use it for, I think, Debian is the other one you can use now. And the idea is eventually in the future, more and more operating systems are going to be like this, and this is going to be the more mature way of deploying stuff. So I was hesitant to move over to NixOS because you're stuck with the way they do stuff. If you don't like the way NixOS does something, you're stuck with it, and I didn't like that. So for deploying containers and stuff, I thought that it was cool. But then Flatcar and stuff exists where if you really don't need anything and you're just deploying software on something, you just use something like Flatcar or BottleRocket. But yes, it is very similar. Water break. So, what is an image? I did front load a lot of information. We're going to step back. We're going to talk about a lot of the stuff that we spoke about. So, an image image and disk are used interchangeably a lot. It's like if you're say magazine and what clip, it's like same thing, like whatever. Like I'll judge you silently, but like I get what you're saying. So a disk is a block level device, and the image is the captured content. So if you want a better way of describing the two of them, the disk is live, the image is storage at rest, right? The image would be like a QCOW, a RAW, an ISO file, like we talked extensively earlier. Those are image files, right? But the disk is, once you boot that image up, you then see things like VDA, SDA, NVMe 01, N1. Those are the disk, right? That's the actual thing that you work with on the system, right? Once the system is booted, you don't really care about the QCOW2 file anymore, right? So in case you're ever wondering what the difference between a disk and an image is, a disk is the live thing on the system, and the image is what is like the raw part. If you were to talk physical hardware, the image would be like, the hard drive would be the physical thing. The image would be the hard drive is imaged to load that system, like the image, whatever you install on there. And then when you boot into it, then you boot it into your disk, right? There's some other things we need to talk about. Partition is if a disk is a pie, a partition is a slice of that pie. Now, there are some people out here that probably just like order pizza whole and they don't cut it, and that's fine. You can use one partition for your entire pie, and you can consume the whole pizza all to yourself. You don't have to share it. That's fine. But you still have to partition your disk when you have to create a partition. You can't just use the raw disk. And then on top of that, we have file systems. So the file system, when you create the disk, is the thing that the operating system uses to read and write to that partition, right? How many of you in here are dual Windows Linux users? All right. How many of you have ever used Windows and tried to create a USB and then plug it into Linux, and it's like, I don't know what FAT32 is or whatever, and it's like, I don't understand what this is what's going on, or huh?
No.
Or what is it? NTFS. NTFS. That's what it is. How many of you have tried to plug in? Yeah. So some people know. So you create like an NTFS partition and you plug it into Linux, and it's like it doesn't recognize it natively, and it's like, that's like Windows and Linux are different. There are tools to do that now these days, but historically in the past they were different, right? So what is a bootc image? I guess the question should actually be, what is a container image? Because they are the same thing, right? So they are not the same as a VM image, right? So it is a stack of tarballs. How many of you use Docker? When you download a Docker image and you see it just downloads all these tarballs, right? It's all little chunks of the actual system itself. It's not just like this one singular image. It's like you can't like take an image, like a Docker image, and like move it. It's just like pieces and chunks, of it. So there is no bootloader and there is no block structure to a Docker image. That's like the main, I say Docker, but I mean container image, sorry. If I use Docker, I mean container, it's the same thing. Docker, Podman, OCI, it's like, it's all the same stuff. I'm just familiar with Docker. So this is so we talk about container images. Let's step a little bit back for people who don't know what containers are. We've talked about it, Docker, Podman, OCI containers. If I've mentioned all this stuff before, we're about to go over it now. So what containers are not is they are not little miniature VMs. It is very tempting to think of them as such. Though mini VMs actually exist, they are a thing, and they're really, really cool, by the way, if you've never messed with them. But container is not that. A container is so a VM has like its own hardware, and a container does not have its own kernel. So it uses the host kernel in order to run. So if you're on Windows and you deploy Docker, I'm like 99% sure, but I don't think Docker develops for Windows. I think it's Linux running on, it's Linux running on top of Windows, and so it uses the Linux kernel in that virtual environment on Windows. The only reason why I ask is I don't use Windows, so I just truly do not know the answer to some of these questions.
I think they used to. I don't know if they still do though.
What?
They did have a Windows version of Docker.
Docker desktop?
Yeah.
Yeah, but that runs Linux under the hood. I'm like,
they had a version that you could do it without Linux. Now it runs on WSL, but
Yeah, but that's still Linux.
Now it does, yeah.
Oh, now it does. Yeah.
But you could choose, used to when you install Docker, it would ask if you wanted to use Windows or Linux. And if you use Linux, or stuff.
Yeah.
Well, I don't know if they got rid of it.
Yeah, I'd have to check because even when you do install Docker, those containers are Linux containers and they need a Linux kernel, so they cannot run natively on Windows, as far as I know. Because they do not have a kernel, so it has to come from somewhere. But yeah, that's the only reason why I think about that. Same thing with Mac. Like if you install it on Mac, because I am like kind of a Mac user, sort of. So for my work, I use a Mac. And we had to install I don't remember how it got set up. I'm truly not a Mac user. I do not like Mac at all. It's just not, it's not Windows. It's the only reason why I use it. Containers are persistent, which is a good thing that we're gonna talk about, right? So does anybody not know what persistence means? And I require audience participation. I don't know because I'm just going to gloss over it. I really hate to. Okay, well, I'm going to go over it anyways because I'm assuming some people don't know. So it just means that the system remembers itself, and if you make changes, those changes will not.
They don't disappear.
Yeah, they don't wait. Oh no.
They persist.
Oh no, VMs. Yeah. I saw. Oh yeah. So yeah, containers are not persistent. Yeah. I'm sorry. I'm reading what they are. So containers are not persistent. So yeah, if you make changes, it says in containers they do not persist. So if you make a change and you restart your container, the changes are gone. That's why you have persistence with volumes and bind mounts and stuff on Docker. So. It's designed to be like that. It's also designed to be isolated by default. However, it does not make it isolated in the sense that it is more secure. It is designed to be like that, to be more secure by being independent of your system. However, there is a such thing as container escape. I did a talk about it, I think, a year or two ago at OWASP. You know, it just assuming that because you're deploying software on a container that it's magically your host system is magically invulnerable to it is idiotic. So, and then the most important part is containers are portable. If I make a container and I'm running on Fedora and you're running it on Debian or you're running Arch or you're running Windows or you're running Mac, I can create and I can distribute to everybody and it will run exactly like it was on my system, because containers are designed to run the same on every system with the exception of CPU architecture. That's the only thing I'll say. And if you're smart and if you're a smart developer, you will just design for multiple CPU architectures. So containers are built using a container file, which is a file that instructs how the system is going to be built. And we will go over container files in a little bit. Containers are built from the container file. When the container image that is created from that set of instructions is built, it goes to a container registry, right? So the registry is where that software sits in that state, that the container that you built it, right? You can upload to the registry and then you can pull from the registry. Docker Hub is a container registry. You can run your own container registries at home for free. Harbor, I think, is like the more popular version. Like what I think that's what Docker Hub runs on. I think maybe, I don't know. Harbor is a very popular I don't want to say open source. Is a popular free hosted solution. And the container itself consists of the image, network, persistent storage, etc. And it's time for a demo with Docker. Cool. All right. So,
Dun, dun, dun.
we don't know if this is going to work. All right, so I'm on my jump box. All right, I think the next thing is demo Docker 01 local CTOS. Cool. All right. The next thing that we're going to need is GitLab. No! I have to change that now. Frick!
Hold on.
Access. GitLab.
Shut up. No, it's not my password. And that was not my password manager password. That was not my password manager password. Thank God. Holy cow. I let my finger go immediately. I was like, nope. All right.
Doesn't matter. It's been recorded by frames.
That's fine. It is my local user password.
A video feed by frames.
No, it's always getting changed when I get home. It's only useful for internal to my environment. So once you're inside my environment, you have literally free access to everything with that password.
So we gotta keep you here all night.
I'll kill this.
Got something. I
We're gonna get that here. Yeah, you gotta get on my system right here. Okay, we're gonna need to go to. I have so many GitLabs. Here we go. This one right here. We'll edit. I need to fill. How do we? By the way, using Bitwarden, if you were here for our last presenter, founder of Bitwarden, pretty cool talk. It's on our YouTube channel. It's really cool software.
It was a good talk.
It was a really good talk. Yes.
It was
And-
worth being overly hot to listen to.
It was very hot. All right, so here is our repo. You can access this repo without my password for free by going to gitlab.ctosio/pub/lug/today's date 2026-07-14. Or you can just go to gitlab.ctosio/pub and you can just navigate your way there. All right, so for the first demo, there are allegedly 3 demos that we're going to do. So I'm going to show you guys what a container file looks like. Let me go ahead and let me just clone this real quick. I'm so mad right now. Sudo. I'll live, but that password won't. It's going to die as soon as I get done with this. Let me kill that. All right. Oh my God. Mac has destroyed my. All right, cool. All right, so demo 1. So, can everybody kind of see what I'm doing? I know if I need to make it bigger, let me know.
Can you make the text bigger, please? Can you move your shut up?
Okay, what?
Control Alt click off of your screen.
Yeah, we'll do it in a second. I just want to make sure you can read that.
Make it one more size bigger.
Good? All right, cool.
So everybody in the back that can't read that.
All right, so here we have a container file. This is the container file itself. This is the set of instructions. If you see from the very top right there, the from Alma Linux 10, it's actually pulling from an existing image that's already built. So that's Alma Linux's pre-built Alma Linux 10 image. This is, by the way, this is a container image. So this is an Alma Linux container, not a VM, right? You add arguments in here like the build date, because as a software developer and a Are you checking? Are you watching the stream?
Yeah.
Someone all
Yeah. All right.
is watching.
The,
All right. Anyways, so
text is still there.
so we have the container file. We showed you the container file. This is the build structure of the container right here. It starts
Your screen's still live.
right there. And we're gonna bake in the image version, the build date, and we're gonna also add the rest of the arguments are here for building the image. This is a little bit more complicated than just basic image. We add our tags in here, pretty much everything to build, and we're just gonna go here sudo, get it here, sudo bash. All right. I tested this earlier, so I know it doesn't take like an hour to do. And it's done. I already downloaded everything, so it's, we're good. So we've now created the container file. I can do sudo docker image it. My computer. Huh?
You missed a D there.
Sure did. Now it's all caps. Docker images. My God. Images. LS, I believe, is.
LA?
I know, I can typing with a delay. Nothing I can do. All right. Is it not LS?
Image.
Oh, yeah, that's right. It is singular. Yep. Image tech LS.
There we go.
Is it not? Is that not it?
Dash in front of the LS.
Huh? Double dash?
No.
Oh, that.
Oh dash.
Image LS.
Yeah, just image LS. There you go.
There we go. All right. So you can see on here,
We got there.
we got the three on the bottom underneath the Zot. Those are our container images. It is the same image, but you can see there's 3 different tags. There's a latest tag, a 1.0 tag, and a 1.0.0 tag. So the reason why you create different tags is because maybe you have different ways of tracking. Sometimes you might have a version. Sometimes you might have a build date. And then some people are masochists and they just like using latest and they just deploy the latest no matter what. So yeah. Yep, that's that. The next part we're going to do is we're going to take the image and we're going to now ship it off to a container registry. If you guys know what Zot is, you know that's what we're using for our container registry. So,
And if we don't know what that is?
it's a container registry. And it already exists. So that would have just been the upload. I'm just going to show you guys what it looks like. It would be demo Docker 01 C2SIO.
Lesson here is download containers from local cache. That's the fastest way to get them.
Yes. I don't know why. Demo Docker 01 local CSIO. That should be it. That's not what I want.
Hit Control A,
Huh?
look through your history to find it.
It's not on this computer. I just booted this computer up for like the first time in 3 months, not long ago. That is the, yeah, it's running. 1 second, let me just see the IP address. Oh, you know why? I'm not even on, here's why. I'm not even on, 1 second.
Yeah, on the network.
All right. It helps to be on my home network. And you'll see that it's, boom, it's magically in there. This is our Nginx image. And we're now going to go back to here, and we're going to do the last thing, which is we're going to create the image locally. So we're going to pull the image, which it is, oh yeah, that's right, yeah, so. That's not what I wanted. There we go. Sudo bash, yeah, cool. So the image already exists, resolve reference, blah, blah, blah. Oh yeah, fuck, I dealt with this earlier. I'm not dealing with this. I've dealt with this earlier. I'm not doing this before. We don't have a lot of time. So essentially the image is already installed. We already built it, the image on the system. We uploaded it to the registry, so there's no need to do that again. So what we're gonna end up doing is we're just gonna I'm just gonna cat these instructions. And I'll just run the file itself. Oh, you know, nope, this is it.
Your image has to point to your local registry.
Oh, yeah, I see, that's why, yeah. That's right, yep. Why is it not? Yeah. No, registry. That is, what the heck? I literally tested this out for, whatever. We'll test it out for a few more seconds, and if not, we'll move on, because Docker is not the important thing about this talk. You said, Docker pull image, it pulls the image, that's the image there. Oh, I see, yeah, it doesn't point to the registry. It should just be this. Not that. I believe this is what it needs. No. What am I doing? It needs this right. Here, I should just put this like this. There we go. We're gonna do it this way. Oh, come on, I just pulled it, or I just grabbed it. It's not letting me. That is not the, it's not copying this text over for whatever reason. Hey buddy, I can click Control C and it's, yeah, it's not copying over. Sudo docker pull demo dot, demo slash docker slash 01. I'm gonna take this. The whole thing, image. Actually, you know what? Let me just do this. I wonder if this works. Yeah, there we go. We'll just Nginx. That works. Demo docker. Does it need to be? Let me just do localhost, I guess, because it is localhost.
I don't think you need the port on there.
Are you sure? I don't know. This is not working. The point of this talk is not Docker. I don't want to get too wrapped up in this. Essentially, you can. We're just going to do sudo docker run tacd name web 8080 80. We won't worry about a volume right now. I think that's it. Oh yeah, the image name. Docker image ls.
You need the Docker.
Yep.
There.
I'll grab this. Docker run d 80. I believe that's a web. Cool. And it's still not working. What the heck? Oh, container already used by. Okay, so the container already exists then. So, all right, whatever. The container is already running. So if we go on to this, if we go on to demo docker 01 local c2s io 8080. I need to spell it right. Local. I mean, that is, yeah, it's running. Yeah, it's running. Oh, we might have not attached the volume. Either way, I'm not getting caught up on this. This is not the purpose of this demo. That's Docker in a nutshell. I did not focus on building this entire presentation around Docker. If it was, it would have been more fleshed out. But I wanted to kind of just do a very brief short showcase on Docker. Let me resume. What the fuck, dude? I don't know how this works. Does anybody use Google Slides?
Top right.
Yeah, there you go.
Where's that?
Slideshow.
Oh, yeah.
You could also probably just use F5.
Will F5 work?
Alt F4.
No.
Okay, whatever, it starts there. Cool. All right, we created a container file. We did upload it to the registry. We attempted to pull the image, and we attempted really hard to build the container. We actually succeeded somehow, but we couldn't get to the page. Time for Bootsy. Cool. If you guys thought Docker was easy, wait until you can find out about Bootsy. It's gonna be way easier, way better. All right. Bootsy. We're gonna take the same principles that we have. The build ship run is not a very static, it's not the way that we do it. This is just how I'm describing it for this talk. But you build the image, you ship it, you push it out, so you're pushing it to the registry, and then when you're running it, you pull the image down, and then you start you pull the image down, you have to convert it from a container to a QCOW image, and then you run the system. So the conversion part is something that we haven't talked about yet. So we've already talked about what Bootsy kind of solves: system drift, images become immutable. That's an important factor for this, is that these are immutable images. How many people here run Bazzite? You said you run Nix, right? Anybody run Bazzite? All right. I had the pleasure of helping my friend troubleshoot his Bazzite computer the other day, and boy, it is not Fedora. It was a headache. But it's completely different. It's an immutable system. It is designed so that it is like stateful, right? Like you can roll things back very easily if you make a mistake. Changes aren't affecting the system itself, right? I'll show you what that means. The concept is very similar to containers if you're familiar with it. You can create golden images, right? With a reproducible point in time, if you want to start from the beginning or whatever. One thing I do want to cover real quick is Bootsy is a relatively new technology. I believe it's only been around for 3 years now, roughly. So it is relatively new. We are talking about something that nobody here has 10 years of experience that they could put on their resume for this. It came from similar projects that it came from would be like RPM OS Tree. Fedora Silverblue is another one. They are immutable atomic rollback capable systems, roll backwards and forwards. Changes are made. The Bootsy changes the packaging and the distribution. We've talked about this, how we've previously rolled out images before in our environment and how we're using container registries and pulling them down now. And the operating systems, again, are treated like applications in the sense that that's how you develop them, upload them, and then that's how like your whole entire CI pipeline works. So, boy, if you thought the Docker demo went well, wait until Bootsy demo happens. Great. So excited. All right, demo 2. I swear it worked at home. All right, number 1. We're going to go ahead and what is it? Docker prune A is the command to get rid of everything? No, what is it? Oh. You know what? When in doubt, tac H. When in doubt, clot it out.
Dan's telling you twice.
Huh?
Dan's trying to tell you.
What is it?
Do Docker prune -H. It should give you the helpful.
Oh, that's this is the help. Prune. It is. That's what it is. Oh, Docker image prune. That's what I forgot.
Oh, wait. Yeah.
Image prune. Yes. There we go. That's what I missed. Cool. Anyways, I just wanted to clear out everything so that way we could start kind of over from fresh. Let's first start off with the container file. I showed you guys what the container file looked like for Docker. It is quite similar for Bootsy. Instead, you are pulling a Bootsy container image. You cannot use them interchangeably. They are different. Same thing, top to bottom. The only difference here is that we added a little bit of automation. So I added a users and an SSH script in here under the build. So what I basically did was I created shell scripts. So when you build the image, you're executing those shell scripts in that build process. The ones that I actually did, let me go back real quick because I want to see, did it include packages? It does not. It's supposed to. I don't know why it's not in there. Anyways, we're not worried about it. So what I did here is I created shell scripts. You have, for example, packages. This is a shell script right here to install packages on the system. Did not do tab. There we go. Very simple. DNF install the package. What are our packages? Let's find out. It was packages.txt, was it? Yes. These are the packages, and then you just list whatever packages you want to install. Curl, fail2ban, git, JQ, wget, sifs, everything in there. So what that does is when the image builds, it's just going to go run that, hey, install packages, and then it's going to reference this text document, and it's just going to install the packages. If I want to change this image and add another package, I just go in here and add the package instead of going in and installing it manually on my system, and then I can redistribute this to my fleet of thousands of Linux VMs automatically.
How do you specify versions?
I think it's the same way like with DNF, you just add, I think, what is it, colon, and then the version number afterwards, if that's available. But yeah, this literally, if you look at how it is, all this is just a script that runs and then references packages.txt. I wrote this. This is not specific to boot C. The fun thing about this is that anyone, and I will show you my Frankenstein setup that I have after this presentation if we have time. But this is the cool thing about this is that the skeleton is there, the creative mind is, you know, right there in your head and also on Claude. Same thing with SSH. So SSH .sh references the keys and then our SSH conf. So cat jaxlog.conf, or we'll do keys first. This is a public key. I'm not scared, and also it's for a demo. And then the other one is ssh.conf. As you can see, it uses, it's basically editing the SSH config file. I'm trying to be nice to you guys. It updates the config file, adds the authorized keys file. It says, hey, no password authentication, we're only doing SSH authentication. Permit root login, no. So, you know, I mean, you're hardening your system more with these configs from the default config that it supplies. So, with that all being said, and then users, we'll just go over users. I'm not going to go over the users install, we're just going to go over users conf. Right there, it tells you the user, their UID, GID, their home, home directory. If you'll notice, the home directory is not home jaxlug, it's var home jaxlug. We'll talk about that in a minute. And then their shell. So with that all being said, we're gonna go work, please work. It will take a lot longer, trust me, if I didn't have everything cached. It would be downloading the entire Alma Linux 10 image, which takes a couple minutes because it's pretty big. But if you thought that we just installed a Linux distro, boom, it was that fast. It was that fast. We added our user. Now, if you add more configurations, you add more packages to install, obviously it's going to take longer. But I mean, can you install a basic, like we added stuff. Like, it's not like we just did a basic install like we did, like when you go in and you do it before. We actually added more packages for it to install, right? So we actually did more than just a basic ISO install, and it was done that quickly. Again, if this wasn't cached, it would have taken a little longer to download the image, but you know, usually you might have those cached on your server to reduce the time. But also, if this runs automatically, you don't really care because you're not looking at it, and it'll probably just run when you're asleep. So, like we said, we did that. Now we're going to ship it out. So I don't know if this will work because it's actually, you know what? Let me do this real quick. Escape. Let me go here. I don't know if I can delete this or not. Go back. If we can't delete it, no biggie, not a big deal. I don't think we can. Yeah, we can. Delete. Kill. Die. All right. All right. We're gonna ship it out. Already exists. It's fine. Whatever. If we change the version number on it, so like let's say for example, this is a perfect example actually. We're just going to change the version number on here. Let's do, we're going to say that this is 0.1, right? So now we're going to build it again, right? So we made a change, right? Now we didn't actually make a change, I just changed the version number. But like, let's say for example, we added a package or two, or we added a user, or we changed our user's password. You know, boom, it's done, version's done. I believe, did we do the 01? Oh, no, I see what we did. I think it's actually in here where I defined the version number. Yeah, here, we'll do that here. Sorry, I have to redo it again. That's not it. Sudo. We'll do image version. We'll just do. I'm just gonna change it here. 2.0. Cool. All right. And we'll build it again. It should be version 2 now. We theoretically made a change.
Woohoo!
It changed to version 2. So now when we go to upload this, it shouldn't say, hey, it already exists. So again, the blobs already exist. So we'll talk about this right here real quick. So remember how I talked to you about how container images are not the same as regular images, that they're bunches of blobs. The cool thing is that when you're uploading the image, or arguably if you're downloading or updating it, if the blob exists already and it hasn't been changed, it's not going to re-download it again. So if you've downloaded maybe a 1 gigabyte container image, right, and it's on your system, and then there's an update and you re-download it and you try to re-download So as you can see now, we have our version latest and our version 1, and I don't know where version 2 is. I also don't really care at this point. But I didn't build this in. I'm just changing stuff on the fly. So ideally, we already uploaded latest version 1, version 2, or version 1, version 1.0.0. It's on there. If we wanted to pull it, we could. And we're going to do that, exactly. So in the third part of our demo, yeah, it is really slow right now, this connection. All right. Container registry. Good, we do. Localhost 5000. We reference the image. This worked at home. And then we convert the image. So if you'll notice, we're using the container runtime, and we've described that as, I believe we're using, Podman. Where's that? There it is. Yeah, so we're using Podman unless we define it otherwise. I can't remember why. Again, I don't know everything, but you have to use Podman for this, not Docker. I ran into some issues before, which is fine. It's literally the same thing. Like, it doesn't make a difference. So you are, just like you execute Docker run, right, to execute and deploy your container, we are using Docker run or Podman run to build the image itself with these arguments right here, right? So we're gonna run this, and I wanna show right now, there is 3 build scripts, or there's 3 scripts that build in the container file. So if we, now you wanna be fast. This is the part that takes the longest. You are unpacking the system, you're unpacking the image, and you are converting it. When I'm running these at home and my runners are building the images, they take roughly 20 to 30 minutes. It could be faster, they could be more optimized, but they're trying to build like dozens of images at a time. So like if you have one VM that's running 10 build jobs, like it's gonna be slower. But it's free and it's my infrastructure, so I don't have to worry about it. But understand that like this takes a while. It's not gonna take 20 minutes. We're building one image. I'm doing it on an actual dedicated VM instead of a container runner, so it won't take that long, but yeah, we're building. Anybody have any questions right now? I know this might be a little complicated, and you're probably sitting here like, I had you in the beginning maybe, or I lost you in the beginning. I had you in the middle. You're like, okay, images, disks. We had some issues with Docker. We revived ourselves with Bootsy, and then I just plopped a VM on here, and you're like, okay, I don't understand how we got from point A to point C, and now we're at Zulu. So it's like, I understand this is like months and months and months of learning and studying, and I'm teaching you guys it in 2 hours.
Yeah, so does the bootc container have the kernel built in?
Yes.
It does.
Yep. It is a VM.
Okay.
Yep. It is a virtual machine. It is built with the kernel inside. When you deploy these as VMs, they deploy just like any other VM would, as if you had created it from an ISO file. There are differences. I will tell you them in a few minutes, but there are slight differences. If you notice, one of them earlier, I pointed out the home directory. So, if anybody knows why the home directory was in var home, anybody want to say if they know?
Partitioning?
No, it's not. But you're kind of close, sort of. So, boom, it's done. So it didn't take that long. And if you look now, we have output file. We have QCOW directory. And then in here we have our disk.qcow image, right? Pretty cool. That will run a VM right there. Now, remember when I talked to you guys about how it was immutable before? And how if you make, you can't, if you make changes to it, it won't stay. And the same applies for this also. This is an immutable system, right? So, what is the directory on Linux that, what is the directory on Linux where you would mount your data partition if you had one?
Anywhere I want.
True. I would argue you probably couldn't load it in certain areas, but var is universally where you would put, like if you had to mount a disk, it would go there. It's typically where it will be in containers, although it depends. Containers are also weird and different in the sense that you could just mount things on top of, whatever. It's whoever makes it and builds it, but like with Linux VMs, there are certain directories, especially if you go in there and you're like, what's the SVR directory or SRV directory, which nobody ever uses, which I, by the way, use all the time now. When I found out that like it's not even used, it's where you would use, if you had a server, you were hosting a service on it, you would put all of your files and stuff there. And since we don't do that anymore, we just have containers and stuff, and everything's in Etsy and var. We just, yeah. So I will say this, everything is in var. It will be var user, or not var user. Actually, let's do this. We are actually in right now, the system that I'm running, demo Docker, was built with Bootsy. So if we go to here, the root directory, right there, you can see. Mount is var mount. Home is var home. The root home is var root. You also have, what is it? Yeah, that's pretty much it. So, if I wanted to install something, like if I wanted to install, I'm trying to think of a package that I would want to, that I don't already have installed. A random package that's really super easy to install, like lightweight. HTOP? I think I already have HTOP installed. I already have curl, huh? BTOP? Yeah, sorry. I already have curl. Sudo dnf install BTOP if it works. It can't. I don't know if you guys can see that. Bootsy system is configured to be read-only. You cannot install stuff on this. It is an immutable system. It is read-only. You can bypass this. You can get around it and say, hey, I want to install stuff. It's great for testing. If you reboot the system, it goes back to the way it was before. Just like Docker, right? Immutable, can't make changes that you make, they're all stuck in time, right? So how do you update this? Does anybody want to have a guess how you would update this? Because if I go in here and I do sudo dnf update, I'll do y. I run into the same issue. I can't update this system. So how would you update it, do you think?
Build a new image.
What if you're not the maintainer and you just download the image, right?
Build a new layer.
Yes. So in here, actually I have to pull up the command because I didn't put it in the slideshow for some reason. I don't actually, the funny thing is that this image is running the latest version, but if I were to do sudo bootc upgrade, what is it? Upgrade, apply. Oh, I see why. This didn't come from a container registry. Okay. Anyways, this image, my images are built differently and they're deployed differently. I actually run them. I don't actually go in here and do this, but the normal way of doing it would be you would pull this from a registry, and if you wanted to update it, you would just update it this way. You'd go in here instead of doing like sudo dnf or apt upgrade or whatever. You would use the bootc command to upgrade it, right? And it would then apply the next version of the container that's that's available, right? And it will pull that for you, and it will do it live on the system, right? Really, really cool that it does that. If you need to revert back, you can revert back to a specific version, like a moment in time when it worked before, right? Because as we're aware, as updates are pushed out over time, those older ISO files adapt to those updates, right? So here's a perfect example, right? If I needed to roll back to an image from 2 weeks ago, and part of that image meant that I needed to download HTOP the way it was 2 weeks ago, how the heck would I do that, right? Unless I had an image that was already built that way. But if I needed to revert, it's difficult. But if your images are deployed as in a state where it was, you just revert back to that state, right? So traditionally, if you needed to say, oh, I need to deploy I need to recreate an image the way it was before, you could do it. Like you could go and say like, hey, I want to install this software with this version, but you have to do that to everything. Because as we all know, software is constantly being updated, right? Which is why we like containers, because when software developers deploy containers, they work in a point in time. They have a state, right? I'm emphasizing this to everyone right here in that you will save a lot of headaches if you move to this new way of deploying server images, right? You can do all this at home for free and for fun. It is really cool. We still have a little bit more slide left. We are not going to cover the rest of the presentation, but I will go over it because it is important to understand why we're actually doing this. So we've talked about containers and we've talked about bootc, right? So now how do we kind of make it like, give it a little white dust, right? We add version control, automation, and infrastructure as code. This is where we take what we've made and we turn it into something completely different. So we're gonna start by adding Git. Git is our version control. It's also really awesome for collaboratively working with multiple people, which if you work on a team of engineers, you're not usually, well, hopefully you're not usually working alone. And if you are, you're probably underpaid. It allows you to track changes that are made, do proper version control. Slide was not made with AI. And for Git is software that you install. By the way, Git, famously made by Linus Torvalds, also developed on Linux kernel. GitLab, like GitHub or Git is a platform where you can host repositories of your code, and it also acts as like a CI/CD tool that you can use. It's really, really cool. I'm not certain, I'm like 99% sure GitLab is not open source, but GitLab is free, and you can use their community edition. And by the way, their community edition is insane. Like, I host all my stuff on GitLab. I don't recommend the casual person to do it because GitLab is actually a pretty big monster. But if you, and GitLab is not the same as like, I'm trying to think of like another example, like a monster like Open, what's it called? Like the cloud infrastructure, Open,
OpenStack.
OpenStack, if you host OpenStack at home, you are truly psychotic. OpenStack is not a one-person job for paid people. So if you're doing it for free, you should seek help, right? So GitLab, on the other hand, is crazy, but at the end of the day, you can underutilize GitLab. You can ignore a lot of the big features and maintain it. OpenStack, on the other hand, you have to know everything, and if something breaks, dear God, you have no support, and that's OpenStack is crazy. By the way, I did evaluate whether or not I wanted to use OpenStack. I avoided it and went OpenNebula, thank God. But yeah.
Isn't OpenStack mainly for enterprise anyway?
Yeah, but it's free, and but here the whole purpose of this talk is to design your home lab to be enterprise parallel, so that whenever you can upgrade your resume and you can go to people and you say, hey, I don't know how to just do home lab cool stuff. I know how to do enterprise stuff. So
OpenStack underpins things like AWS.
Okay.
yeah.
So like if you want to get into cloud engineering and are crazy like me, OpenStack is fun.
OpenStack is good.
Do you host OpenStack?
You can host, huh?
Like 10 years ago. Yeah. I'll do it anymore.
Yeah, because you have a life now. It's like I said, what we do in our 20s and 30s, we don't do in our 40s and 50s because it'll sap, I promise you, it will sap the life out of you. So
It will make you retire early.
So again, but if you do want to get into cloud engineering, there are other tools that I can recommend to you, especially AWS. There are other tools specifically designed to learn AWS without paying for AWS. And you can run stuff at home too. So, you what?
OCI has free layers.
Yep. So GitLab, there is no GitLab demo. I showed you my GitLab. Actually, I'm going to just do it real quick again. This, boom, right here. This is my GitLab. This is no different than what you would see on GitLab.com. Make me sign in. How dare you?
Don't do it.
Oh no.
It's alright, we didn't see anything. We all saw his username.
It's autofill anyway. It's not mad. It's not a big deal.
Well, but it is.
Verification.
Oh.
Well, I'm not doing that. So anyways, this is what it looks like on GitLab.com. Like very much looks like it. And the cool thing is you actually get, even though if you're using like the community edition versus what they offer you for their SaaS solution, you actually get way more control and features that you probably wouldn't get on GitLab's, because you but I don't really care.
Edit that part out.
Yeah. So anyways, yeah, so that's GitLab. Let me get back to the slide.
Now you're hosting your own GitLab, right?
Yeah. Yep, I hosted all on my own. And I'm actually crazy. I hosted in a Docker container, which by the way is not as crazy. Like I would not recommend people to do that because it is more mature to use a VM. You can use a Docker container, and they don't explicitly say, hey, this is not for production. You can run in production. Actually, if you want to, the best way to run it is in a like Kubernetes cluster. I run in a Docker container. I haven't had too many issues. I actually migrated my GitLab instance today. I retired because it was running on like an old Rocky Linux 9.6 VM that I haven't upgraded in like 8 months. And if you know anything about Linux vulnerabilities in the last 8 months, you know why it's crazy. And I migrated off of that today. It has been a massive project. I have had lots of different steps and parts to it. And eventually I reached the part where it's like, hey, migrate. And I did the migrate. So it wasn't that hard, but I would have preferred to have installed it on its own VM. Anyways, GitLab, So why would we use GitLab? We can store all this code that I was showing you in the terminal would be stored in GitLab. Actually, got news for you. It is installed in GitLab because we pulled the registry. It's right here. We're the repository. This is literally right here. Infrastructure as code with Terraform. Guess what? Remember what I said at the very beginning of my presentation? Does anybody remember?
You don't like HashiCorp?
I don't like HashiCorp. So we're not using Terraform, we're using OpenTofu. But I will still call it Terraform because that's just, I don't like OpenTofu. I think it sounds dumb. So we will still call it Terraform. Sorry, they just need to pick a better name. So who knows what Terraform is? I asked this because my friend Champ Clark, who I talked to about a month or two ago, this was a very humbling experience. He was like, I've never heard of Terraform before. And me, in my mind, I'm like, how could you have not heard of Terraform before? You know everything. And I was like, and it was really cool because I was like, there's so much that we don't individually know because we are all learning as we go. Like there are tools that I know about that other people don't know about. And there are tools that you guys probably know about that I'm probably don't know about and you're gatekeeping it from me. Why aren't you telling me about it?
Oh, damn.
So yeah. Anyways, Terraform is super cool for you guys that don't know about it. It is the same thing we talked about with Bootsy. Stateful, declarative, like this is a theme that we're running on now, right? But it is the infrastructure portion. If we talked about images as like the image itself, the infrastructure is the VM that uses the image. So now we're making stateful infrastructure for our VMs. What does that mean? Terraform does not know your tools. It operates off of it's provider based. So you have to use a Terraform provider, which is all that is just a part of Terraform that knows how to like make certain API calls to a tool. That's all it is. Somebody has to write it, somebody has to maintain it because as we all know, API calls change all the time. Terraform does not create its tool around those other tools, right? So if you think about it, it's really cool in that aspect. If it doesn't exist, you can build it. So I believe the providers are written in Go. I know Terraform's written in Go. I believe the providers are also written in Go. So it's really not that hard. If you want a cool, fun project, building a provider for something that is not already built. Again, stateful, immutable. Terraform also does not mutate or modify. It obliterates and creates, right? What does that mean? It doesn't make, if you make a change to a VM, it doesn't change the VM, it nukes it out of existence and then just rebuilds it again. Why? Because changing is bad. You don't want to make little mutations and changes because then that's how you get deviations. You start over and then you create it new, right? And it maintains that state in its files. Terraform commands, you got initialization, you got your validation command, plan and apply, and then format and destroy. Destroying, is it format? there are different here. There's different stages, or not different stages, but there are different sections. So we have one right here for Bootsy and one for Terraform. So ideally how this would work is we have the Bootsy pipeline that runs and builds the images independently of Terraform, right? And we kind of want this to work this way. You can make, the other option would be to make Terraform dependent on Bootsy, meaning that if Bootsy fails, Terraform doesn't, it would be like a stage kind of way, that Terraform doesn't start operating. But the only reason why is that you don't want to make it dependent on Bootsy is that if you make changes to Terraform, you don't want it to be dependent on Bootsy failing or passing or not, which is why you separate them, right? They're two completely different things. They operate independently of each other. I was going to have a pipeline built, but cool thing is I actually already have loads and loads of this already. I'm praying I don't show you guys something I'm not supposed to.
Just edit it out later.
Yeah, I see. Thank you, Timekeeper. So this is what maintains all of my images right here. Is this repo, or for my Bootsy images anyways. So let's click around carefully. There aren't any secrets in here, but there's things that I definitely don't want. There we go. So I will just show off, start from the beginning. So I organize things into little templates here. I have base images, core images. This infrastructure is inherited from the old way of when I used to do stuff, and I haven't transitioned over to the new way. But all that means is core is like I installed the image, made no changes. Base OS is I made changes like adding users, and then base is I installed specific packages like Docker or like stuff for hypervisor or whatever, right? So, let me go ahead and, click into this. So an example, let's go into base. So in here, we have, let's go with Docker. So for Docker, I run two different files, right? I have a Bootsy YAML file, and I have a config file. So the YAML file right here is very, very simple. It tells you what type of image it is, base. Again, that's irrelevant, that doesn't matter. The role, Docker, the OS var, which is Alma 10.0. And the reason why I have role and var is those are used to build the name of the image. So none of this is super important, and enabled just means that that job is enabled. If I disable it, it disappears from the pipeline. Great for me developing stuff in my development environment without having it actually say like get GitLab errors, like saying, oh, you broke this or this. It's like, whatever, I don't care. So, and then the config file, which is actually has the most important stuff, the registry up there up top where I pull it from, the base image, the release version, right? I control my release version, so I don't depend on saying like, I'm not gonna say, hey, run 10, because if they make a change in 10.2 that breaks 10.1, I don't want that. I want this to work, and I want it to be stable. I can set the host name. I always set a base default host name. And then the interesting part is the layers, and I'm not gonna go into this in detail. I would if we had more time, but essentially, for all of my Bootsy images, I have layers on how I install stuff. And if you notice, you have at the platform layer, meaning, hey, this is for all RPM-based distros. I'm not gonna worry about that. The platform for all RPM-based distros, distro for Alma Linux. So it says, hey, the changes that I make in here are specific to Alma. They won't work on Rocky. Rocky will get its own distro version. The infrastructure, Bootsy. So if I make a change on here, I don't want it to be made for KV Mage. This is good for like little scripts, like, oh, I need to make this, like for example, there's a script that I had to add because there was something that was broken on Bootsy that wasn't broken on KV Mage, so I had to fix it on there. And then sites, for my home network, I'd made an entire site saying like, hey, we're gonna use these base users, we're gonna use this SSH port number, we're gonna use this all across my home infrastructure. So that's what gets hit there. And then the module is Docker, and that's just basically saying, hey, this image is for Docker. All that does is just install Docker and Podman. That's literally all it does. And I can show you those real quick. It's under scripts, modules, and then Docker. And this is just a script to run Docker and install Docker. Same thing for Ceph. This is a script to install Ceph. You have OpenNebula. This is the script to install OpenNebula. And I create these scripts, I store them here because here's the interesting thing. I reuse them. So might be an image that I say, hey, I'm gonna install this specific image. A good example, my GitLab runner. My GitLab runners need Docker. So why would I write a whole different script for my GitLab runners when I can just write a reusable Docker script or a reusable script that just installs Docker and I can just use it for all the images, right? And then I have 2 runners. Here's the cool thing, if I make a change to the way I run my Docker script, it applies to everything that uses it, right? So, again, these are all custom scripts and modules and things that I've built. The Bootsy is just the thing that sits underneath. It's the way that the images are built. It's not necessarily, like this isn't Bootsy itself. One other thing too that you'll notice that I don't have container files. I have a script that builds the container files from configurations that I make in my environment. So like you saw earlier where I said, hey, this is the registry, this is the version number. There's a script in here. I believe it's the, it's the build script right here, I believe. This build script, see right there? It makes the container file for me and it just uses all this information to make that container file, which is pretty cool. Lastly is, I'm gonna show you guys what it looks like. Let's go to pipeline here. So today I had to build, manually I had to build some production images and it failed because I already fixed it in my dev environment, so I just have to push it to prod. There was a change in the GPG key, and I have to push that change out. But if you look under here, Alma Linux 10, this is the entire, and you can actually see it installing the operating system. These are all the packages. It's installing just like a regular operating system. And then in the very end, this is the thing that I don't do. I don't have a registry for these yet. I'm working with, I want to host a registry. The issue that I'm running into right now, and if anybody knows the solution, Cloudflare restricts file size uploads. You can get around this. It's very, very easy. You can't really chunk this. At least I've run into a lot of issues with chunking tarballs. It's just the way that container images are built. So the workaround that I've been using has been an internal registry, but it's not part of my main pipeline. So my alternative, the images to QCOW in here, and then just ship them to another server. So I actually don't use a registry right now. I ship them to a server and I manually manage their updates. I don't manually manage it. There's a script that I run that updates them. It's not the best way to do it, but again, this is something that I wasn't doing a few months ago. So this is all brand new infrastructure that just came up a couple months ago. So I know it's a lot. I know that it is you probably have lots of questions, or I probably bored you, or maybe you've lost you probably about 30 or 40 minutes ago. And I certainly know that I don't sound like an expert in this, and that's because I'm not, because this is something that I'm constantly learning. And I wanted to share it with you guys, and hopefully maybe you'll go home and you'll say like, hey, what is this new technology? If you're interested, you don't need to look up Bootsy exclusively. Look up what people are doing these days with containerized image deployment. It's super cool. I think MKISO is one. MKISO is one. I know I was talking with Dan. Actually, no, it wasn't talking to Dan. It was Yehuda, who's not here tonight, I don't think. I was talking with him. He had just came back from a massive Linux conference and was just telling me all this cool stuff to look up. There's so many cool things out there. Do not get yourself caught installing Linux in 2026 for your servers using just an ISO file and clicking through the install. At the very least, use a Kickstart or a pre-seed file. But if not, I encourage you to try this. You don't have to have this fancy CI pipeline or whatever. If you're building the images manually, like if you have scripts on a VM and your whole thing is I'm just running it on a VM, you're doing way more than, I'm gonna be honest, than a lot of enterprise environments. Because like I said, this is like 2 to 3 years new. So this is your opportunity to learn something that most sysadmins aren't even doing today. This is new. So if you can get in on the ground floor on this, you know. Any questions? I'm here to answer what I can try. Yes.
What are sysadmins doing instead?
So
It works on my machine.
I can tell you what I've been exposed to, which is scary, because if you are not a sysadmin and you talk to a sysadmin, it is I guess the equivalent of like a psychologist talking to a psychopath. They use like golden images. They'll pull golden images. They'll have, like I said earlier, they might use like Ansible or Cloud Init to create these. Amazon has its own golden images, their AMIs. So like they'll just pull the AMIs, they'll customize them, and then they'll use that. That's totally fine. That's how we've been doing it for a while. This is just infinitely better. You're talking about right now, and again, the cool thing about this is I'm a vulnerability management expert. What is the one thing that I have struggles with? Is sysadmins updating their freaking systems. And let me tell you, you click update, it doesn't update 100% of your systems. There are systems that fall off. There are systems that fail in the middle of an update. And managing, and Rob's here, right? Yeah. How many systems do you manage again at work?
We have over 200,000.
That's a lot. That's a lot.
170,000 Linux boxes.
That's a lot. You'd be crazy to think that some sysadmins are going to care about.
We still have 2012 Windows 2012 servers.
Me too. Me too. Me too. High five. Yeah. So this is actually like, you know, if you're a security professional, like you can. I'm trying. Trust me, I'm trying in my organization to say, hey. So a lot of this knowledge that I'm gaining is to help our organization too. To say, hey, they're not going to listen to me. I'm just going to be honest. Sysadmins are stubborn, but it's here. So are there any other questions? Oh, did that answer your question? Yeah. Are there any other questions? I'm happy to answer what I can. If not, yes.
What do you use for local caching?
For local caching? I mean, I have a couple of cache servers that I run, but like for Docker, for example, I have like a local Docker cache server. The VMs themselves also cache images, but I have a cache server that I run. It's like, I think it's like one VM that has an NVMe drive that's like tied directly to it, so it can be as fast as hell. But it's got like a 1 terabyte NVMe drive connected to it, and it literally just caches all kinds of stuff. So,
Would this work for like OpenBSD or stuff like that, or is it just Linux?
This is Linux, as far as I know. Yeah, this was only restricted to, like, bootc was restricted to RPM-based distros until not long ago. But yeah, this is Linux. Unfortunately, I don't know very many people that are running like dozens of OpenBSD servers in their environment. But I could be wrong.
So VM upgrades and rollbacks, that can all be done live, right? Or do you still need to?
Yeah, it can be done live.
Okay. Keep your rollback afterwards if something goes wonky.
Yeah, the only thing that I was talking about that was an issue is, again, as part of the upgrade process, sometimes things are not graceful. I'll give you an example. I had to upgrade my GitLab server, I think a month ago. It was like 3 versions behind. I had not touched, I'll tell you, this thing was neglected for a long time. It was running on an old 2-year-old server. I had to upgrade it, and when I went to upgrade, I didn't read the documents. It did not boot. It did not start, and I had a backup, and I restored the backup, and I just went for it. And I was like, all right, there's a process. So I went on GitLab's website, and they actually have a really, really cool tool that they use to guide you through. It'll say, hey, what version are you running right now? And what version do you want to upgrade to? And it provides you detailed steps on what you need to do for each part of the upgrade. And I thought it was really cool. And that's what I used, and it took like an hour to do it. But what happens is if you have to revert backwards, you don't have, you can't just revert back, right? You gotta have a backup. Yep, you gotta back up. Which was one thing I didn't mention to you guys earlier, is one other thing too. And then we're done. But we have this room, we're not getting kicked out. So I'm gonna log into my production, not my domain controller, my production hypervisor.
I want to show that.
I don't care.
You got prying eyes.
I don't care.
Okay.
Pause for 0.
You know which prying eye that I'm talking about, right?
Okay, let's see here. Let's use the IP address. All right, this is my production domain controller. Yeah.
One of the ones in the watching might be him.
Cool.
Somebody was asking about BSD. So I was talking with Dan, and he's like, yeah, I don't see why you can't use Ansible BSD. And there's a whole community for, Ansible community documentation on it. The actual Ansible documentation.
So here is the this is the actual VM that we're running on earlier. This isn't my hypervisor. I wanted to show you something really cool. If you look over here, you'll notice I have 2 QCOW images loaded onto, yeah, I don't know why they're named the same thing. These should not be named the same. Yeah. But yeah, these are not, yeah, this is for a demo anyway, so I fat fingered it. It's not controlled, but there's 2 of them, right? So one of them, VDA, is the main image, right? The other one is the persistent storage. You have to load persistent storage on top of it. So where does it get loaded onto? VAR. It gets, when you mount it onto the system, you will want to add it to the VAR directory, and then from there you'll get most of the your stuff. Now, are there directories on this system that you can change that are not persistent? Yes. Etsy is one of them, right? You need to be able to make changes to the system, and Etsy is a directory that needs to make changes to. However, Etsy will not persist, and the reason for that is because if you want, that information wouldn't be stored. Like, if you were to, like, let's say for example, you want to migrate from one server to the other, you don't want to take the data that's stored on Etsy and put it on that other new server. Absolutely not. All you want is the data that's going to be persistent to what the application that you're deploying or whatever you're using, right? Etsy still needs to be changed, which is why it's there. So if you need to change the host name, the IP addresses, the network interfaces, whatever, you would want Etsy to be able to be messed with. Now, here's an interesting thing. If you were to go and you were to take the same image and you were to go in here and plop it in there, it would erase everything, right? Your IP address, your host name. That's not how you upgrade this. You upgrade the way I showed you earlier with Bootsy upgrade. But yeah, you need a persistent storage on there. I do mine automatically. I label these with a tag, and then what happens is I have a script that runs on boot. It detects for that disk with that tag, and it automatically mounts it to VAR before the system even boots. So it doesn't matter what this image is named or whatever, as long as it's attached, it's gonna get mounted and added to VAR. And that's where you get that, from. So I wanted to mention that because that's really important. And again, it's not something that it's not something that works out of the box. You have to design and engineer that. So are there any other questions at all? None? Cool. Thank you so much for showing up tonight. I know it was a long talk. Lord, I know it was a long talk.